Welcome, students. In today's class, I am going to discuss about the that one behavior of dielectric in capacitance. Okay, so if we insert capacitance, half filled, fully filled, or different dielectric slabs, then how the capacitance will vary. We are going to discuss this particular concept in today's class. Okay, it will help you solving the questions of NEET, JEE, board exam, etc. Okay, it is from electricity potential and capacitance. As you know, my name is Amarnath. You can connect me through this WhatsApp number for any sort of doubts and queries. Okay. So, first of all, let me discuss when a capacitor is, say, partially filled with dielectric. Okay. Because when it is fully filled, already you have discussed that capacitance K times increases. But if it is partially filled, then what will happen? Let us discuss. Okay. So, you please draw along with me. Huh? So this one is a capacitor. One plate is say grounded. Okay. Okay. The separation is D. As it is, we take normally plate area. I take A, separation B. Okay. This is common. Okay. Every time I'll be taking like that only. Now I am putting a slab. Okay. Dielectric slab of the dielectric constant say K. And the thickness is T. Okay. Which is less than D. So some empty space will be there in the capacitor. Okay. So then what will be the net capacitance of the system I am going to discuss. Okay. So let us have a parallel plate capacitor partially filled with a dielectric slab of thickness T and dielectric constant K. Well, so as you understand that if the potential of this left plate is say V, okay, because I have given a charge Q, and the other plate will be 0 only, okay. I have given some Q charge. So here negative Q will be developed. Okay, here potential will be 0, so potential difference is V, okay. So that V will be divided into three parts. Now here I can say this part is of V1, voltage drop here it is V2, voltage drop here it is V3. Okay, like that we can assume that. Because total voltage is V. So V1, V must be equal to V1, voltage drop here plus voltage drop here plus voltage drop here. Okay, this is like that. Well, V equal to what? V1 plus V2 plus V3. But remember, V is nothing but field into distance because field is uniform now here. And one more thing, field at this empty space, I'm taking E naught, and the field at the dielectric, I'm taking E. Okay, and you know that E is nothing but E naught by K only. We have already discussed in our previous classes. Okay, so the total voltage equal to field into distance. Okay, say this distance is for the timing I'm taking at X. Okay, this is X, this is T, and this part will be D minus T minus X like that. Anyway, plus. So here in this dielectric slab, the potential difference is field into that one. Okay, that gap is T, but field is E. Okay, E into T plus, and for the last part, that is nothing but E naught into that the empty space, which is nothing but D minus T minus X like that. Okay. Anyway, so if I break it, okay, what I get E naught into X plus this is nothing but E naught by K. I have already told you. Plus E naught D minus E naught T minus E naught X. So E naught X will cancel. So remember, whatever answer you are going to get, it is independent of the position of the dielectric slab. Remember, because X is eliminated now. See, X is not there. X is actually you can say the position of the dielectric from the one plate. So as X is answer is independent of X, it means if you place the dielectric here or somewhere here or in contact with the other plate or in contact with the first plate, the answer will not be different. Okay, it is independent of X because it is now here down. No, okay, V equal to. Now let me simplify it a little bit. E naught is taken common. So if I take the E naught common, then I can say from that E naught I can take D okay, plus, and then again here also T, here also T. So if I take T again common, then I can say 1 by K plus 1 like that. 1 by K by K minus 1. Okay. Bracket into T, double bracket. Okay. This is that. And you know that E naught is nothing but charge by sigma by epsilon naught, and sigma is nothing but Q by A. So V is written as Q by A epsilon naught, okay? Because Q by A is sigma bracket D plus bracket 1 by K minus 1, okay, into T, double bracket, okay? That Q by V ratio is the capacitance, na? Because charge held divided by potential difference created. That ratio is called capacitance. So that is why Q upon V is equal A epsilon naught whole divided by this whole term, bigger term, D plus 1 by K minus 1 into T, okay, like that. So this is nothing but the capacitance, okay? Q by V. Q by V equal to what? Epsilon naught D plus 1 by K minus 1 into T, okay? So you can keep it in a box, okay? Remember, I am going to derive it, okay, similar situation if I am having multiple number of slabs, okay? But we will derive it in a different way. You see, you can also derive this also that way also. You see, say this plate and this plate, okay? And I have inserted a dielectric slab. Okay, I can insert more also, more than one. Now you can see here, this is also a capacitor only. You can say it is C1. This is also a capacitor. This is also C2. This is also a capacitor. This is C3. All C1, C2, C3 are in series. So 1 by C equal to 1 by C1 plus 1 by C2 plus 1 by C3. Like that also you are going to get the same answer. Okay. You can try, okay, for as a homework. Okay, now this is the final answer. But now you see, if I can say two situations, say T is 0, okay? T is 0 means there is no dielectric at all. So T is 0 means this term will be vanishing. So A epsilon naught D will be there, okay? A epsilon naught D by T is 0 now. T is 0 means A will not be there. If T is 0 now, this whole part will be vanished. A epsilon naught by T will be, okay? We know also this thing now. If dielectric is not there, the answer is this. And what I have taken E naught, I have taken as the field in the empty space, and E I have taken as the field in the dielectric. Okay? And your answer, final answer is independent of the position of the dielectric, okay? Because X is not there. No? Answer is independent of the position of the dielectric slab. Copy all these things. This is one of the important reactions that may be coming in your exam. So now let us discuss how the potential will vary from the left plate to right plate, okay, as we go. And the electric field, how does it vary when we go from left plate to right plate, okay, like that. So let us first discuss it. Left plate has a potential V, okay. The right plate has a potential 0, okay, because it is grounded. Let me draw, okay. Say vertical axis is say V, okay, potential as a that one which distance, okay, from the left plate. So field is constant, so potential will decrease. Field is rightward, so it means always potential decreases in the direction of electric field. So, but decrease will be uniform, okay? Decrease will be uniform. So say this is the first part, this is the second part, and this is the third part, okay? It means this is the position of the second plate, and this is the position of the first plate, okay? So this total distance is D, and that dielectric portion's distance is T only, okay? So first of all, potential will drop down uniformly, okay, like this. But in the second case, slope will be little less because field is less, no? Because slope of voltage versus distance gives you the field, no? E equal to minus dV by dr, okay? So here the slope will be little less, okay? And again, here the slope will be same as that the first one, because this is also empty place, this is also empty place. Na? So field here also E naught, here also E naught. So potential gradient should be same here. But at the midpoint, it will be little less because it is having less field. Okay. So this is the overall graph for voltage versus time, that one distance. Okay. So if I now discuss about the variation of electric field, okay, with the distance. So as I have already discussed, okay, say vertical field, that one axis is electric field and the horizontal is say D. So let me, total distance, these are the three slabs. One is air, second is the electric medium, third is again air. And here the electric field will be constant only, okay. Thickness T, field will be constant, okay. If it is E naught, then here it will be little less than this, okay, but it will be constant only again, okay. So if it is E naught, this will be E naught by K, but again it will be E naught, okay, it will be again more. So this is the graph for E versus D, okay. So you please copy the graph and let me know. And you also imagine, say this is a metal, okay. So K will be infinity. It means field will be zero. So this will not be like here. It will be just at this position only. Okay, zero electric field. Okay, like this. Because in metal field is zero in electrostatic cases. Now let me discuss actually if the capacitor is if says different dielectric slabs are there. Okay, not only one. Say we have 2-3 dielectric slabs are there inside the capacitor. Okay, parallel plate capacitor. So let us proceed. Okay, say this is a parallel plate capacitor, and I am having some dielectric slab. Okay, so this one is a dielectric slab of thickness say T1 and dielectric constant say K1. Okay, exactly that way. This one is another slab of thickness say T2 and dielectric constant. Okay, and so on. You can say. Okay, say let me draw one more. Okay, T3 and K3. Okay. We'll discuss a pattern, okay? And from that pattern only we'll understand the final result, okay? So you see here also we'll derive now with a different way. You see, this will also be a capacitor. This is an air capacitor. And these two faces also constitute a capacitor. It is a dielectric capacitor. This is also a air capacitor, dielectric capacitor. Or you can say that we have two different type of capacitor. One is air capacitor, another is dielectric capacitor, like that. We can say. And all will be in series. All will be in series between the left plate and right plate. Why? Because voltage goes on adding here. If charge passes, the charge will be same everywhere. That is why. So capacitance of a capacitor having multiple dielectric slabs. Okay. So what we can do, 1 by C dash. C dash is the equivalent capacitance. Okay. Is equal to 1 by C1, I can say. Okay. So what is C1 you see? That part's capacitance. Okay. Capacitance. So capacitance of this capacitor will be what? Between these two surfaces, it will be K epsilon naught A by D. Okay, K is K1 here, epsilon naught A by T1. Okay, that T1 can be written as at the top. Okay, as a numerator. Okay, because 1 by C, na? So plus for the second, again 1 divided by K epsilon of A by T. Okay, K2 epsilon of A by T, T2. So, and so on. Okay, if we have three dielectrics, it will be, you have to write 3, 4, 4 like that. Okay, so I'm writing just okay, just dot. And remember, this is only for the dielectric capacitor, but one air capacitor is also there. Na? This one. As a whole, I can say that the capacitance of the air capacitor will be what? It is nothing but epsilon naught A divided by the gap. Gap is not T1 here. You see, total distance is D. So D minus T1 plus T2 plus T3 like that. Okay. Because air gap will be what? Total distance minus the dielectric gap. Okay. Dielectric distance. So it will be D minus T1 minus T2 minus T3 and so on, okay? As much as we have dielectric slabs, we have to add that only, okay? Now I am going to have some mathematical treatment, okay? 1 by C dash equal to, if I take 1 by epsilon naught A common, okay, because it is everywhere, then bracket, you see, here it is T1 by K1. Here it is T2 by K2, and the third term will be T3 by K3, T4 by K4, like that, na? So it means I can write sum of Ti by Ki, okay? Here I is from 1 to n, okay? If you have n number of slabs, it's a real formula, okay? I'm writing plus, and this is D, because epsilon of A is already taken out. This is only D, okay? Minus. Now you can see this is nothing but T1 plus T2 plus T3 up to Tn, okay? It means it is nothing but sum of all T's, Ti, okay? Again, I is nothing but 1 to n, okay? Bracket close. So this is the general format, okay? Sum means just adding of all discrete way. Now, but I need C dash only, na? So C dash equal to what? It is epsilon naught A divided by this part, okay? As a whole, this part. This part is just Ti by Ki plus Td minus, okay, Ti bracket close, okay? As a whole, we can say like that. You can keep it in a box, okay? Here also we can check different cases. If T is not there, okay, sum of T's are 0, means dielectric is not there. So simple formula epsilon naught by D only, okay, like that. If T is 0, then formula is A epsilon naught by D only. And if all that one K's are, say, K1, K2, K3, K4, all are K only, okay? It means everywhere all are dielectric, all dielectric slabs have dielectric constant K only, okay? Then what will happen? And sum of all T's are D, okay, total. It means single dielectric only now, okay? So it will become K epsilon naught A by D only, okay? It means whole place is occupied by a dielectric of dielectric constant K. So this is the main formula. This is the main formula, okay? So, but other tools are already, we can derive from it only. So please write all these things and let me know. Now let us practice some question, okay? Say a situation I am giving you, just try to answer it, okay? First, say a dielectric, a capacitor is there, parallel plate capacitor, okay? But we have a few dielectric slabs in between, okay? So this one is a dielectric slab, okay? Covering the whole area, but thickness D by 2, okay? And dielectric constant, say it is K, okay? And I have another one dielectric slab that covering the area A by 2 and thickness D by 2, okay? But dielectric constant 2K. And this one is again area A by 2 and thickness D by 2 and dielectric constant 3K. So now you need to say what is the net capacitance between the left plate and the right plate, okay? You think for a few moments and I'll discuss it, okay, after that. Okay. Here actually, we can see, say this one is a capacitor, okay? That is C2, okay? I mean, I'm taking it as a C2. And I'm taking this part's capacitance as C1, okay? This part's capacitance as C3 and this part's capacitance as C4. That is C4 and that is C1. C1 is from here to here, okay? So why I have done this, you see. Actually, I could have done this way also. Say I'll take these two as parallel, okay? And whatever I'm getting the result, I'll add with this as series, okay? That left part. But that will be a wrong, okay? Why this is wrong? Let me explain. First of all, this C1 and C2 are not parallel. Actually, to be parallel, na, so we should have the same voltage, okay? But here you can see, say displaced potential is say something displaced potential is say something V2. So displaced also will be V2 only. But remember, displaced potential and displaced potential will not be same. Because you see, dielectric constant is different here, na? So the potential drop will be different, okay? As here the slab is K to 2K, but here the slab is K to 3K. So drop will be different at different positions. So what we need to do, operate as C1 and C2 are in series, C4 and C3 are in series, then the combination of C1 and C2 and C4 and C2 are in parallel, okay? That way we have to do. So let me first write what is C1. C1 is nothing but K epsilon naught A by 2 D by 2. So it means it is K epsilon naught A by D. So what is C2? C2 is nothing but 2K epsilon naught, again A by 2 by D by 2. It means A by D only, okay? So C1, C2, I got it. So C1 and C2 are in series. So C12 as a whole will be what? It will be, we know that C1, C2 by C1, C2, now when two capacitors are in series, we have already discussed this. So what is common here, you take it out, okay? K epsilon naught A by D is common. So what is uncommon here? Here it is 1, here it is 2, okay? 1 into 2 by 1 plus 2, okay? Like that you can do. So it is nothing but 2/3 of K epsilon naught A by D, okay? That is C12. So now exactly what is C4? C4 is nothing but K epsilon naught A by 2 by D by 2. So it is nothing but K epsilon naught A by D. Okay, 1 by 2, 1 by 2 get cancelled. So C3 will be what? C3 will be 3 times, okay? 3 times K epsilon naught A by D. Now C3 and 4, they are series. So similarly, we can say that 1 into 3 by 1 plus 3. It means 3 by 4 K epsilon naught A by D. Now you can say that C12 and C43 are in parallel, okay? Therefore, C12, 3, 4 as a whole, as both are parallel, this and this are parallel, so you know that when parallel, they get added only, na? So K epsilon naught A by D under bracket 2/3 plus 3/4, okay? You take the LCM, this is 12, then 4 to the 8, then 3, 9, na? A epsilon naught by D. So ultimately answer will be, calculation part, you please check it. Okay. This will be the final answer. Please understand it and copy it. Okay. I'm going to give you one more question. And again, please try to understand why this is so. Okay. Now let me try one another question. Say the situation is like this. Okay. Again, one slab, two slab, three slab. Okay, like that. Similar way, D2, D by 2, D by 2, A by 2, A by 2. Okay, like this. And dielectric constant, say K, 3K, and 2K. Okay. Whatever coming to my mind, okay, I'm just giving like that only. Uh, then find the capacitance, okay. Please try it. Okay. So in this question, I can directly say that C1, okay, say this is C1 and this is C2. So they will be in series, okay. But whatever the result, it will be parallel with C3, okay. So C1 and C2 are that one series. So C1 is again epsilon naught 3k A by 2 by D by 2, no? Because this is D by 2, this is D by 2, this is A by 2. So you can directly write A by D, okay? And C2, capacitance is 2K, 2K epsilon naught A by D, okay? So what will be the, as they are in series, so total capacitance will be multiplied by their sum, no? So K epsilon naught A by D is common. So 3 into 2 by 3 plus 2. It means 6 by 5, okay? So this is the series, but now the what is C3? C3 is you can say see here, distance is D, not D by 2 now, okay? But area is A by 2. So it will be K epsilon naught A by 2 and distance is D. So that is okay. So now I have to just add it only because these two are parallel now. So C1 to 3 or as a whole it will be just I need to add it. So K epsilon naught A by D, then bracket 6 by 5 plus 1 by is nothing but 5 to the 10 only. 12 plus 5, 17. Right? So K epsilon naught A by D. Okay. This is the actually final result. Now let me discuss another situation. Okay. Say this is a parallel plate capacitor, but this time actually dielectric slabs are in that way. Okay, angled way. Say it has a dielectric constant K1 and it has a dielectric constant K2. Okay. Other parameters are same only. Plate area you can take as A. Okay. And the gap you can take as total gap is D only. Okay. So what will be the capacitance between the upper plate and the lower plate? Okay. So that is the question. So you please think of the situation because we have to integrate it as a whole. You please think of the situation first and I'll discuss it. Okay. Find the capacitance of the capacitor of the plate area A and the plate separation D. Okay, let me derive, okay. It will be a big integration. Anyway, what I do here, you see. See from the left end, okay. Quite visible, no? Okay. Now, from the say left end, okay. Okay, and from the left end, say at some x distance, okay, I have taken one small slab, okay, of dx thickness. So this is X, this is dx, okay? This is dx. Dx. So in this portion also you can see this one is a capacitor, okay? Very small capacitor, of course it is. Say this is DC1. And this portion also having a capacitance, say this is DC2. But remember DC1 and DC2 are in series, okay? Because I'm talking about the net capacitance between this plate and this plate, okay? So that DC1 and DC2 are in series. So first of all, let me understand what is DC1. DC1 is nothing but capacitance of this portion, okay? So this one's, you can take it as DC2 because dielectric constant I have taken 2 now. Okay. Say this is DC2 and this is DC1, okay? This plate's dielectric constant K1 and here it is K2. So now think of DC1, okay? So DC1 is, you can say K times K1 times epsilon naught area. Okay, what is the area here? Okay, what is the area of this portion? See, this is also we should understand. Say this is the plate area, okay, of the capacitor, like this, okay. So the thickness is dx and the breadth is say b, okay. So it is b dx. So K1 epsilon naught b dx divided by the gap, okay. Say this gap is something y, okay. So this is y. So similarly, what is DC2? DC2 is nothing but a capacitance between this, okay, this slab. Because thickness is very small, so I can assume this is a parallel only, okay, plate. So what is DC2? Again K2, but plate area will be this much only. Epsilon naught B dx by. But remember, if it is y, then this portion will be d minus y because total distance is d. We have already assumed. So d minus y, okay. And DC1 and D2 are in series. So net will be what? Multiply by the sum only. DC will be multiply by their sum. So you please try to bring out all quantities which are common. Epsilon naught B dx common, okay. Then rest of the quantity K1 by y into K2 by d minus y divided by K1 by y plus K2 by d minus y. Okay, multiply by their sum, C1 into C2 by C1 plus C2. This is common, that is why I have taken out, okay. So you have to simplify it a little bit, okay. It is a long integration, but you have to do it, no problem. The epsilon naught b dx, so it is K1 by K2, sorry, K1 into K2 by y into d minus 1. Then this much, if you take LCM, okay, y into dy, that will go up, y into d minus y. LCM, it will go up, and this part will be K1 into d minus y. Just a minute. K1 into d minus y plus K2 into y. So y into d minus y into d minus y got cancelled, okay. So what is left? DC equal to epsilon naught b because dx is variable, so I have written dx here. Then K1 into d, if I break it, okay, K1 into d minus K1y, and this is K2y. So it means plus K2 minus K1 into Y, okay? Because see, X is also variable, Y is also variable, no? Here X is this, okay? I can take X anywhere in the capacitor. And as if X changes, so Y also will keep on changing only. So both are variable. So now we need a link between the X and Y, okay? I need a link. So how can I get the link? You see, this is Y I have taken now, and this is D minus X. So Y by D minus X, Y divided by D minus X is nothing but tan theta only, okay? This is theta, perpendicular by base. So which is nothing but total distance is D and total length is L, okay? Total distance is D, total length is L. Because they are similar triangle, no? Like that. If it is D, it is L. If it is Y, and this portion is D minus X. Because this is X I have taken, no? I have taken this is X, and that is Y. So from that we can say, from this we can say D minus X is equal Y by D into dy, sorry, Y by D into Y. D minus X equal to Y by D into L. In fact, you should write like that only. L by D into Y. Now, if you differentiate it, okay, if you differentiate it, see, D is a constant. Only X and Y are variable. So, if you differentiate it, you can get minus dx equal to L by D into dy, okay? So, it means in place of dx, you can write this minus of L by D into dy. So, it means dc equal to epsilon naught b. In place of dx, I am writing L by D into dy, L by D, or you should better write L by D here only, L by D into dy divided by, see, it is K1 D plus K2 minus K1 into Y, okay? But with a negative sign. Yes, because negative sign is also there, na? D minus X, this is minus dx, na? Now you see, this is the important thing. If I take the DC here, okay, then the value is this, okay? But I can take the DC here also, no? I can take here also. Even I could have taken here also. So all DCs will be in parallel, na? Because they are under the same potential difference, upper plate and lower plate. So it means if we integrate all DCs, because they will be added only now. So net capacitance will be nothing but the integration of all DCs, all these dy by some things, okay? So you please copy all these things now, and I'm going to integrate it, okay? I need some space, so I'll rub it. And once you copy it, just let me know. Let me free up some space, okay? Now C is equal, you see, epsilon naught B into L is nothing but total area of the plate only, because total area is that breadth B and length L only, divided by that D and integration of this part, okay? It is nothing but A plus BY type integration, okay? A plus BY integration of, you see, dy A plus by type indication. So I hope you know it. Okay, it is 1 by A ln, sorry, 1 by B ln A plus by only. Okay, its integration is. So similarly, if I put here, it will be 1 by K2 minus K1 and ln K1D plus K2 minus K1 into Y. It is the standard integral. Or you can prove it also using substitution method. But limit will be from remember, limit is a little bit interesting. Limit actually, you see, when the x is 0, na, y is actually d. So initial limit will be d only, yeah? And final limit will be 0. Okay. It is not from 0 to d, it is from d to 0. Because I have taken x from the left, na? So when x is 0, the y becomes d only, na? Total. That is why. And this is why that minus 9 sign also will be that one. Cancel out also later. So it will be epsilon naught A by D K2 minus K1. So if you put the ln, this is y is 0. So it is ln K1D. And now if I put y is D, then you can see K1D and K1D will get cancelled. That is also K1, na? Minus K1D. So it will be just K2D. Okay. With a negative sign. DD will get cancelled. So final answer is what you see. Final answer is, if you remove the negative sign, epsilon naught A, epsilon naught A by D K2 minus K1 ln that K2 by K1. Okay. This is the final answer actually. Because you have to remove the negative sign also. Okay. So that you can interchange it. Na? It was ln K1 by K2, but I am writing now ln K2 by K1. Okay. So this is the final answer, okay, for this type of situations. We have to keep on integrating, okay. So you please copy all these things and check the calculation part once more. Okay, let me discuss force on a dielectric slab by a capacitor, okay. Say this one is capacitor, parallel plate capacitor, okay. And I'm going to place a dielectric slab at the mouth of the capacitor, you can say. Plate area A and separation D as I have taken. So this is that one, okay. Dielectric slab. So let me connect it to a battery. Okay, when we connect to a battery, so charge will be deposited. And due to the induction, actually, the dielectric also will get polarization effect. Na? So some charge will be deposited at the face of dielectric also. This is positive, this is negative. Okay. So actually, we are going to discuss a case when the battery is kept connected. Okay, what will be the force on the dielectric slab? When the battery is kept connected. Battery kept connected means the potential of the capacitor remains same. Okay. If the dielectric slab insert also comes also into the gap of the capacitor, but still the potential difference will be remaining same because the battery is there. So that is why I am going to discuss the situation force on a dielectric slab by a capacitor when the voltage is constant. Okay. Similar derivation comes when charge is constant also, okay, but that will be a different part. So when the battery is connected, charge deposited, okay, say this is the positive charge, okay, and similarly on this face negative charge will be deposited now. So now actually what happens, here due to that one polarization, you can say, okay, due to the polarization, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive. Okay, this type of polarization effect takes place na, in dielectric slab, you know. So now you see the positive and negative will attract, na? But this positive and this positive will repel also. But as a whole, you can see the negative is closer, na? So ultimately, I say here it will be positive, okay, positive, negative. Because it is negative, na? So positive will be closer to it. So positive will be attracted, okay? So altogether, you can say that net force will be attractive only, okay? When the whole dielectric is inside, na, then net force will be zero. But now, of course, force will be there, na? Because this positive will attract the negative, okay? This will repel the positive also. But repulsion will be little less. Same thing. As it is negative, it will attract the positive, which is closer. So attraction will be more. Because of that, actually small that one, okay, contribution only. The force is there, okay. So what I assume that assume that the dielectric slab is already injected by an amount x, okay. Because you see, we are going to now derive it, okay. What is the force on the dielectric, okay? So let me understand it, okay? Say already X amount of dielectric is already inside, okay? Total length you can take L, okay? So it means L minus X will be outside, that empty, okay? Like that. Okay, this part has a capacitance, okay? You can say C1, which is uh, having dielectric, and this part has a capacitance, you can say C2, which is not having any dielectric, it is empty now, okay? So if we talk about that, it is a parallel plate capacitor. We can just see the face, okay, top face like this only. This, okay, B breadth is B, you can say. Okay. So here C1 equal to what? C1 equal to, we know that is simply epsilon of A by D and multiplied by K, na? Because dielectric is there. So it is equal to K times Bx. Bx is what? You say B is the breadth, X is the that of length of the area of the that of, okay, this plate into epsilon naught by the separation. Separation is D only. But for the C2, K will not be there. Okay, as simple as like that. Okay. For the that C part, K will not be there, and length will be it is for this length is X, but for this it will be L minus X like that, divided by D. And you know that these two C's are parallel only because they are under the same potential difference. Now, this plate has a potential say V, this plate has a potential say 0. Okay, difference is V minus 0 only like that. Okay, we can say. So they are parallel, so they will be added only. Okay, net capacitance is nothing but C1 plus C2. As simple as like that. Okay, let me add it now. C is equal. C1 is what? A B X epsilon naught by D plus B L minus X epsilon naught by D. Okay. Now, what is common? B epsilon naught by D is common. So bracket Kx plus L minus X. Here we can take X common also, and that will be coming as K minus 1 like this. So C equal to, calculation part you please keep on checking. B by epsilon naught by D under bracket. So this is L, okay, and plus I can, if I take X common, so K minus 1, okay, bracket close. Now you see one interesting thing. As the capacitor, as the dielectric slab goes on, that one goes inside the capacitor, its capacitance goes on increasing. Okay, it means it is a differentiable. C is varying with X. So if I differentiate C, variation of C with X, so what I'm going to get, you see, dC upon dx. Okay, how the capacitance varies. Okay, that may also be a separate question for you. So you can see here one is, that is L is constant only, but this part's differentiation will be simply K minus 1 because you see dx by dx 1 only. So B epsilon naught by D into simply K minus 1, okay, simply K minus 1 because L part differentiation will be 0. So this is the rate at which the capacitance is changing, okay. But why I have discussed this, you see, I know that energy of the capacitor is what? If the voltage is constant, then I should better take the formula energy of the capacitor as half CV square, no? Equal to half CV square. See, as capacitance changes, so energy also changes. So that's the thing we are going to discuss actually, okay? changing capacitance, how the energy changes. So it means du by E equal to half CV square. Simply we can write V square by 2 into C. So du by dc dx, sorry, du by dx is equal to V square by 2 into dc by dx. Okay. If the capacitor changes with x like this, then energy will be changing by this. Okay. Why I have derived this? Because I know that this is nothing but the force only. Okay. Because negative gradient, sorry, it is the negative of the force. Negative gradient of the energy is called the force, conservative force. Okay, we have discussed already in work energy theorem chapter. Okay, field is minus dV by dr, and the energy is field is minus dV by dr. The dr can be written as x also, no problem. It is if it is along x, and force is equal to minus du by dr. Okay, you can take x also. So then the thing we are going to do here. Okay, so in place of that du by dx, if I write f, then a negative sign will be put here, v square by 2. And dc by dx already we have done. Okay, already we have done. V epsilon naught by d km as well. So this is our final answer. Okay, this is the force at which with which the slab placed at the mouth of the capacitor will be attracted. Okay. And remember, this is a constant force, okay? You cannot say that more will be the x, more will be the force. No, no. You see, x independent, x is not there. So if it is at the mouth, say 2 Newton force is there. If it is, say, 1 millimeter inside, then also 2 Newton only. But this force will continue until and unless whole dielectric slab is inserted in, okay? Whole. When it whole the amount is inserted, na, then of course net force will be immediately become 0. But remember, if you release at the mouth, na, so it will be attracted. So it means velocity will be gained. Because of the velocity, it will go out of the capacitor also on the other side. When it goes out of the capacitor, then the capacitor will pull it back, okay, with the same amount of constant force. It means you can say that if your dielectric slab is released at the mouth, it will keep on oscillating only, okay. But remember, oscillation is not simple harmonic, because force is x independent. But in case of, I think, simple harmonic motion, you remember that force should be directly proportional to x, negative of x. Okay. So here actually the force is constant. That is why it is not simple harmonic. Okay. Slab will oscillate, but not simple harmonically. Please copy all these things. And if you have any sort of doubts, please feel free to ask me. Okay, now let us try this question. That is the ZEE Main 2023 question. A parallel plate capacitor has plate area 40 centimeter square and plate separation 2 millimeter. The space between the plate is filled with a dielectric medium of thickness 1 millimeter and dielectric constant 5. The capacitance of the system is, well, it is a direct question from capacitor partially filled with dielectric. Okay, the formula is, we have already discussed, that is A epsilon naught divided by D plus 1 by K minus 1 into T. Okay. So if I put that one values, okay, area is 40 centimeter square. Okay. So 40 into 10 to the power minus 4, then epsilon naught. D is 2 mm. So it means 2 into 10 to the power minus 3 plus 1 by K is 5. And T is 1 mm, means 10 to the power minus 3. If I solve it, 10 to the power minus 3 can be going up, okay? So it will be 4 times epsilon naught. 10 to the power minus 4, 10 to the power 3, minus 1, and 1 0 is there already. Okay. So that calculation part you can do, no problem. 2 plus, and this is 1 by 5 minus 1. So it means minus 4 by 5. minus 4 by 5. If we take the LCM and all, 20 epsilon naught. 5 to the 10 minus 4 is 6. You divide by 2, that is 10 epsilon naught by 3. C is the excellently correct answer. You are good. You are correct. Thank you. So let me try another question. Okay, that is another question. What it says, a parallel plate capacitor has two layers of dielectric as shown in the figure. The capacitor is connected across the battery. The graph which shows the variation of electric potential. Okay. Electric potential and distance from left. Okay. So these are the capacitor plate. And here up to D, dielectric constant D, F2, and from D to 3D, dielectric constant 4. Okay. Remember, field is actually constant. So if the in empty space, if the field is E naught, then field here will be E naught by 2, and field here will be E naught by 4. Okay. This field will be less. And but we are talking about the potential. Potential is negative gradient only, na? So the slope will be constant. Okay. But here the slope will be more, here the slope will be less. Okay, dVdr. Yeah, you can say dVdd or dVdx. Okay, here they are saying x. So first of all, there is a gradient of potential. So it is wrong because here gradient is 0. It says field is 0 only. So it is a gradient. Okay, this is also wrong. Okay, and now this question and this question, what is difference? Here gradient is more, here gradient is less. That is also true because here field is less. Na? So it means this is the correct answer. And this is wrong because of that reason only, because here the gradient is seem to be more. Okay. It means electric field should be more here, but that is a dielectric constant 4. So electric field will be E naught times the 4. So that is a C option is the correct option. Okay, this is a similar question. A parallel plate capacitor has two layers of dielectric as shown in the figure. The capacitor is connected across the battery. The graph which shows the variation of electric field and distance x. So these are two plates. Separation is 3D, but up to D we have dielectric constant 2. And after from D to 3D means there is a separation 2D, dielectric constant is 4. Okay. So at this place, field will be E naught by 4, which will be less. At this place, field will be E naught by 2. E naught is the field at the empty space, okay? And it will be constant only. So it is saying varying electric field, so it is wrong. It is also saying varying electric field, that is also wrong, because field should be constant. But out of A and B, A will be correct, because this field is more than this, okay? But in this second question, the second option, they are showing the second field is more, which is not possible. So that is why A is correct. In this question, the distance between plates of a parallel plate capacitor is 5D. Let the positively charged plate is at x equal to 0. And the negatively charged plate is at the x equal to 5. Two slabs, one of conductor and other of dielectric of equal thickness D, are inserted between the plates as shown in the figure. Potential versus distance graph will look like. Okay, there as it is positive charge, it is negative charge. So ultimately, direction of field will be in this direction only. Okay, it may be less or more. Okay, at any point, but direction will maintain from left to right only. So it means potential will keep on decreasing only. Okay, but slope will be different. At this point, field is E naught. So it means say there should be some certain slope. But at this point, field is 0. So it means slope will be 0 only for the voltage. At this point, again air, so slope will be same as that of this, okay? At this dielectric, field will be less, so it means slope will be less, okay? It will not be like this, slope will be little less. Then at this point, again slope will be exactly like that, the previous two, okay, in the space. So that is wrong because here you can see the voltage potential is increasing also, but it is not possible because field is always from left to right. So this is correct, okay, out of the 4. This is totally wrong because its slope is not constant here na anywhere. And this is also totally wrong, okay? Because potential cannot be constant at different places. Na? Only one place is there, which is conductor, where potential will be remaining constant, okay? Potential difference 0 and field is 0. So that is why B option is correct. Now let us try this question. There is an air-filled 1 microfarad parallel plate capacitor. When the plate separation is doubled and the space is filled with wax, the capacitance increased to 2 microfarad. The dielectric constant of wax is. So initially C equal to epsilon naught A by D, and which is equal to 1 microfarad, okay? Now in the next case, C dash equal to K times epsilon naught A, and separation is doubled, okay? Doubled. So it will be 2 times D, okay? So K will be equal to, because we want K only, 2D by epsilon naught A into C dash. Now that is epsilon of A by D is 1, 1 by 1 only, okay? And C dash is given as 2. So that will be getting cancelled only. 2 to the 4. So out of the 4 options, B is the correct, okay? Dielectric strength of the slab will be, wax will be 4 only, okay? I hope you have also given. Yeah, you are also correct. Nice. Okay, in this question, I see the gap between the plates of a parallel plate capacitor is filled with isotropic dielectric whose permittivity epsilon varies linearly from E1 to E2 in the direction perpendicular to the plates. The area of each plate equals to S. The separation between the plate is equal to D. Find the capacitance of the capacitor. Okay, let us discuss this. Okay, say this one is plate, one plate, and this one is the other plate. Okay, of the that one capacitor. Now the dielectric actually the permittivity gradually changed from E1 to E2. Okay, as D increases, dielectric constant increases. Okay, and area of the plate is S. Okay, so what I do here, at some, I need to find out the total capacitance, okay, of the capacitor. So what I do here, at some x distance, okay, I take a small separation, dx, where the potential difference will be dV, okay. So we know that dV equal to, that is minus E dot dx, okay. That's a famous, okay, we have already discussed a lot of things, okay. Now it will be what? It will be charged by epsilon naught, okay, but I will not write epsilon naught because now the permittivity will be epsilon only, okay. So Q by A epsilon, okay. Q by A epsilon into dx, okay. Remember this epsilon is varying, okay, different point. How it varies, you see, that is also given in the question. Say this is the epsilon, okay, it is varying like this, okay, like a straight line, because they are saying uniformly, na? So if it is epsilon, if it is x, so as you go on increasing, okay, along x, so it goes on increasing from epsilon 1 to epsilon 2, okay, and this is the d, okay. When you go to d, the epsilon is epsilon 2, and when you are at 0, It is epsilon 1. Okay. So it means you can say that this is a straight line only. No? So equation will be what? Equation can be written as epsilon equal to the slope is u2 minus e1, e2 minus e1 by d, okay, into x, and the y-intercept is e1 only, okay, epsilon 1 only. It is like y equal to mx plus c only, okay, mx plus c, okay. M is nothing but epsilon 2 minus epsilon 1 by d, because this is the slope, no? Perpendicular by base, okay. And c1 is that c is the y-intercept, which is epsilon 1, okay. Now I'm going to put it here, okay. So dv equal to minus q by a dx by, so in place of epsilon I am putting this, okay. Say this part is something I am writing k only, okay. Kx plus c, okay. C is epsilon 1. You can write epsilon 1 also, no problem. Now I need to integrate, okay. Integrate. Remember, when x is 0, the voltage is V, okay. But when x is D, the voltage is 0, okay, because it is grounded. Or you can say that potential difference is V when it is that one 0, okay, and when it is you go to the other point, it goes down to 0, okay, like that. So it is 0 minus V means V minus V. With that minus, I can write directly V only. In the left side also minus V, in the right also I am having a V, okay. A minus, okay, that minus will get cancelled. Q by A. So as you know that this integration is nothing but 1 by K, okay, ln Kx plus C, okay, like that. And limit from 0 to D. Yeah? It is simply like that. So that K is nothing but epsilon 2 minus epsilon 1 by D, yeah? Remember. So it means V equal to, or you can write V by Q, okay. V by Q equal to 1 by A, in place of K I am writing epsilon 2 minus epsilon 1 divided by D, okay. Then ln, so if I put x as D, so I can get K into D plus C, and if I put 0, I can get only C, okay, because K into 0 is 0 only plus C. So this is the that under that on ln part. So this is nothing but 1 by C only, okay, 1 by capacitance. So D by A epsilon 2 minus epsilon 1 ln. Now if you put it now, if you put the values, what you are going to get? You are going to get like that only, ln k2 by k1, okay, like that only. Anyway, let me put it. So what is k? K is epsilon 2 minus epsilon 1 by d, okay. So it means it is epsilon 2 minus epsilon 1 divided by d into d is nothing but that one, okay. Cancel. And C is nothing but plus K1, plus E1, okay. So E1 got cancelled. And C is already, I told you, E1 only, okay. So it means ln E2 by E1 only, okay. So what is the final answer? The final answer is C is equal, because it is 1 by C only, no? C is equal A epsilon 2 minus epsilon 1 bracket divided by D ln epsilon 2 by epsilon, okay. So this is the final answer. Please copy it and try to understand how I have put the approach, okay.